All right, good morning and happy Saturday. I'm planning on doing the LeetCode Daily Challenge for today, September 9th. Share my screen here. We'll start jamming. All right, here we go. Combination sum 4. So we can use each value more than once to go to the target. Cardinality input array is 200, so we should be able to just do DFS plus BT. So that's the game plan. It's 7:32 in the AM. Game plan here is to perform DFS, consider possibilities, target T sum of values X of the input array. X here would be some arbitrary I value, A sub I. Right, okay, so there's a game plan. Let's start jamming. Go. I will be tracking our index. In is the cardinality of array A. If I is equal to N, that's our base case. Return. Combos will be our answer. Go populate it. Equals N. Let's keep track of our total T2. If T was T, then we'll say, actually, let's do this. Do you want to check it? Made the path to. Okay, so let's just call this paths. That's plural. Would be all the paths. Instead of append a copy of the path. So this is his referenced object, right? So that looks good for the base case. And if T plus T plus A sub I is less than or equal to our threshold, right? Then we can add A sub I onto it. Same height value, total plus A sub I. Path dot and the A sub I value and path dot pop it. So it's DFS plus BT. And then the path that we passed here. And so we only want to consider I values. So we can't go any further. And then we'll go to the next one. Got the same total. Okay, I think that looks right. Something like that. So we go through this thing. Walk through the output real quick. A equals 1, 2, 3 for the first example. T equals 4. T is our target, right? So this is 0, 1, 2. N equals 3. Start like same T. Add the ith value once. Ith value again. 0 here, right? 3. First answer. Then we'll pop back and backtrack. Off and backtrack. And we'll spin control back to 2. Then we'll go down to the 2. Right, okay, so possible combinations. Oh, the total possible combinations. You don't actually need to create them. Okay, so returning the total. Hold on. Okay, so that's what that I went through this here real quick, right? Stuck through the code. So plus equals t equals t. Okay, I think that works then, right? So increment the count if we land on this. Okay, let's see what happens here. Should be 7. Oh, no. What do you think called R? It's a typo. It's okay. Output's 1. It doesn't look right. Range. No, I guess we don't need path, right? Path here. Oh, I see. Okay, we always want to. Let's always skip forward to. Okay, how about this? If t exceeds our threshold, just return. Let's just make this 2 the person false always. With and without. Uh-oh, 4. Oh, I'm not getting the backwards ones then, right? 2, 2. This one first. Oh, no, that's the numbers right. Yeah, so this is the wrong answer, right? Most of this is not correct. I'm going to spend some time debugging this a little bit. Okay, so 732 to 740. I think that's the wrong answer. I haven't submitted yet, but 8 minutes. Wrong answer. So first of all, I misread the problem statement, right? Come up with pass, but I'm thinking maybe I do need these paths. I want to start back at see suppose I didn't know. Let's go back to this guy. Check this out. What path is here? Pass. Pass. And then return money for the pass. Right. Yeah, and that's because I'm not going backwards to previous high five, right? Or no, oh, the else. Okay. So let's do without and with. Out with. I need to do. Choose that. Let me get my return. Further. So these are the right answers, but it's not considering the inverted versions. This guy can be inverted, that guy can be inverted, and this guy can be changed as well. We can formulate this count to the 0 and it can for half and pass. If it's greater than the length of the set of the path. Two. Okay, and that's using combinatorics, right? We're at the end. I think that looks good. We'll see what happens, right? Try some other inputs too. And figure inputs 1, 2, 3, 4, 5, 6, 7, 9, 10. And then this is in for let's see what happens. Oh, okay, so that's not right. That's like way off. Okay, so acquired incidental evidence based on the example input. That's not quite right. So I fundamentally need to just go back to the 0th index. So when we include something, we can just go back to 0. Exclude, just go on to the next one. Include, and include it, and then include it back to 0. And path. Yeah, I think we do need to keep track of that, right? Okay, looks good. So the reason this works is because you always go back to 0. It's not very efficient, but I think it'll still work because this is 200. Let's see what happens. So we officially at 746. Oops, 746. 6. Looks like it's going to TLE. Oh, man. It's like 14 minutes. 14 minutes. 14 minutes for TLE 32. Oh, dang. Never going to be able to come up with 32. So that's a corner case I didn't consider. if the sum of a is less than t, return 0. This one is our case. No way, wrong answer now. Oh, 39 million. Yeah, okay. So I'm like way off then. Actually, this is DP coming to us, isn't it? Based on that, we need DP, right? DFS. Okay, so this is fundamentally not. It's a good start, right? But it's not going to get us where we want to go. So we need to count possible combinations. Pretty sure I saw this before, right? I think I saw this about a year ago. Game plan. We need to use DP. And from my experience in studying DP is that the realization of the problem is DP is the majority of the work actually. Once we realize that DP, I don't know, like what kind of DP it is or the recurrence relation or whatever, then it's like the code basically writes itself. But the realization that a problem is DP and being able to understand and see the recurrence relations, I think is the hard part. Writing the code for DP is pretty much the easy part. Okay, anyhow, talk is cheap, so let's see what we can jam on here. So there's one way to reach 0, right? So DP will be our matrix or our linear array, right? And then DP be of size t plus 1, t plus 1, return DP sub t. So here's the deal, right? So let DP denote the count of right, DP sub x, t, and the count of ways to reach total t. Right, and let's start from 0 as your base case. DP sub 0. There's only one way to reach 0. Show base case. Base case. Okay, then the question is, what is the recurrence relation? So then I want to go through the numbers. So we iterate through the totals. So for total t in the range from 1 to t inclusive, right? Build current based upon previous. So for each number x in the array A, so you can say this total t can be reached t minus x in more ways if t minus x is within range. Current total is plus 1 of that previous, or plus 1 of the previous one. So dp sub t plus equals dp sub t minus x. So it's the amount of ways to get there. Let's get here. I think something like that. Then here's our recurrence relation, right? Oops. So basically, remember the past to formulate the future over and over again. So then Okay, so let's see what happens here. Uh-oh. List and oh, multiply it. Right, the DP array. Yes, that is this guy, right? Plus equals just straight up equals, right? So I can go through the total ones. I think that works. And if I remember right, this order seems to matter too, right? Combinations or permutations. Oh, got one. That didn't work. These are get to two. Oh, I think we do want to have it then, right? Yeah, so we iterate through this thing. Okay, let's see what happens here. Okay, yeah, so that is right. Okay, a small difference makes a huge difference, right? So we are iterating through this portion multiple times for each t. And if I don't add on to it, then I'm just collaborating. Okay, so that looks like it works out. Let's see what happens. It is 6 or 7:54. Okay, yay, 7:54. 7:54 a.m. So that took about 22 minutes. 22 minutes for the invitation and Python 3, which is accepted, yay. And then plus one bug. Oof. No, not perfect, right? Have significant room for improvement, so that's cool. Work in progress is what I consider myself, right? So yeah, this is cool, right? So we went from brainstorming a solution where we're doing a DFS with BT with the pass. It didn't work out, and running out of memory. Just running out of memory here. I did slightly misread the problem statement that we're only caring about the count. We're not caring about the actual paths. So I made that slight mistake. A couple bugs. And this is an incorrect algorithm here based on anecdotal evidence of the examples. So at least I tried bigger input and was able to convince myself that that was wrong. So yeah, that's a decent solution. Let's see what I came up with previously. Okay, cool. Yeah, combinations. This guy's permutation. Wait, I get that. Yeah, okay. This is permutations. This is not combinations. This is actually permutations. Combination would be the order doesn't matter. So this is a poor name. This is permutations. And this is correct. This is the permutations, right? These are the combinations. Okay, anyhow, it's pretty much the same thing I came up with previously, right? Does this work? Interesting. Permutations. Oh, each key permutation. Oh, I see. Okay. Interesting. Yeah, bottom up. Yeah, it's quite a bit different. So I'm surprised this actually. Oh yeah, because it is permutations. Okay, so I was thinking combinations. Order doesn't matter. Okay, so the name of this thing is like really cool. Yeah, these are decent solutions. Okay. And then we start with control T. Yeah, so there's our base case. Here's our current explanation. Let's just edit these real quick and I'll just add some emojis. Kind of see what's going on here a little bit easier. So here's our base case. Okay. This relation here. Past to format the future over and over again. Currents relation. Page case. Something like that. Just make it a little bit nicer. Okay. That. Okay, JavaScript solutions. And this is what I meant by the code basically writes itself, right? Once you understand the DP, base case and recurrence relation, fundamentally how the problem works from the bottom up compared to top down, it's much more efficient, right? This is extremely inefficient going through all the permutations, but this is very efficient, right? Just doing the counts. Swinging maps and that's interesting. Okay, so yeah, let's do this here. So base case, base case. Relations. And it's that and Python 3. This guy is in the base case. This guy is our recurrence relation. Do this in Rust. I'm very surprised. Okay, we'll post Rust here. Let's see. Rust. I'll just do the bottom up because doing top down is difficult, I think, in Rust. And the reason top down is difficult, I think, in Rust is because I'm not sure exactly how to capture the outer scope in recursive closure. So I have to pass everything in as a parameter. So it's just kind of like leading with those. Okay, yeah, let me, before I go on the Rust, I'm going to comment this guy before I forget. Here's our base case for the C++ solution. There's one way to reach the total 0. Let's make start. On that. French relation. Define the base case. Okay, that was good. And let's jam on this in Rust and post Rust too. Okay, let's keep track of how much time this will take. I'll finish up and go take my kids. Knife, knives is a vector I32s. Mute DP, vector zeros of size t plus 1. T should be a u size. T equals t and u size. Dokie, return d piece of t at the end here. 4 total. Let's see if dp says d piece of 0 equals 1. There's a base case. T in 1 until t inclusive for x and a. If t minus x exceeds 0, then d piece of t is equal to d piece of t minus x, right? So the value without that guy, and this is a recurrence relation of building the future upon the past over and over again. Relation happen, right? X T as I-32. Right, so then U size. This is verbose and ugly. But Rust makes us do these kind of things. And so this guy, we want it to be less than 0 if it's doesn't work out. Let's run into U size. Okay, that looks good. Let's see what happens. 8 o'clock to 8:03. 30. Value A. What? Really? Oh, okay. Farm things there. Oh, yeah. Okay. We are using that multiple times. I see. Okay. Yeah, we do want to borrow X from A. Okay. And then we need to dereference X since we're borrowing it. It was good. Okay. 8:03. 30 minutes. Station. Press, which is accepted. Yay. Post this and then I'll call it a day. Okay. Yep, good enough. All right, catch y'all later.